So welcome all. I hope you all had a great weekend. Thank you. So yeah, just be safe and stay healthy. So actually, remember what we have done in our last class. So remember, until now, what we have been dealing with was this preferences and utility, right? So we were trying to understand how individuals make their choices. But until now, we actually only considered, right? So we said preferences, and hence we said utility. But remember, you told me that there were some other things which were affecting your choices, right? So what were they? Right? You said that, oh, hocam, so this is kind of what we like and what we don't like, right? Sort of, you can say it in very sort of roughly. We can actually say that. But you also said that, hocam, there are also other factors like our income and what else? You said, right, prices of these goods. So, of goods. And then, remember, you told me that, hocam, there is actually a word that we use, right, for these guys when they come together. So we say that, so what did we say? No, it's budget, right? So this is kind of what whenever we say, you'll see the budget set, it will be, it will have information coming both from your income and, prices of these goods as well, okay? So this is actually, these will govern our budget set. So our choices, you'll see that they will not only depend on what we like and what we don't like, but basically they will also depend on what we can afford and what we cannot afford, right? So, and this will be determined by, right, your income and the prices of these goods. And then you'll see that using these, like, of course, what you like, what you don't like, and then, what you can buy and what you cannot buy, right? What you can afford and what you cannot afford. Then, according to these will all determine the choices that you make, right? So basically, we will say that, so let me write this. So we actually say that you will make choices, okay? So consumers, you will make choices, okay? So actually, in such a way that given your budget constraint or given your budget set, okay, you would like to achieve the highest utility as possible. Okay, so basically this is what we said in the very beginning of this class, right? So we said that actually in the end, we are going to say that you guys are acting as if you're maximizing your utility, but you're constrained, right? You're constrained by your budget. So we're going to say that you're going to maximize your utility subject to your budget constraint, okay? So you will make choices in such a way that given your budget set or budget constraint, okay? We can use these interchangeably. Constraint, okay? You would like to achieve the maximum utility possible. So this is actually, in very short terms, actually we can say that you guys are utility maximizers. Okay? So you would like to maximize your utility, but of course you will have a budget constraint, right? You will be constrained. So it's going to be a constrained maximization problem. Okay? So we're going to see this, like how you can solve this problem. We're going to form this problem mathematically. But first, let's try to understand, again, the economic intuition behind it. And first, let's try to see this graphically, okay? But of course, the fact that you guys are utility maximizers is also an assumption, right? Just as the firms are profit maximizers. So this is also an assumption. And remember what we said, that do you think whenever your grandma makes her choices, right, I'm going to buy this much carrots, this much, beets. You know what beets are? Panjar. So, okay, so whatever, so beets. So actually, so whatever she would like to buy, do you think she's considering, oh, I'm going to maximize my utility, right, and subject to my budget constraint? You would think that she's considering her budget and such, and maybe she likes some stuff a lot. But I mean, she's obviously not solving this problem, right? But what we say that her choices, right, the choices that she make, actually we can explain them as if she had this utility function and she had this budget constraint, and as if she was maximizing that utility function subject to the budget constraint, okay? She doesn't necessarily, she doesn't have to be doing that, right? But we say that we can represent her problem like that, okay? Remember the pool player example that we talked about before, right? The guy just hits the ball, right? But I mean, he's not computing all the physics law or whatever, the resistance of the cloth, whatever, right? So basically, that's why I wrote that. So that's what we will try to understand, okay? And after some point, it's going to be a mathematical problem for us. But now let's try to understand a few things. So first, this budget set, right? So how do you think I should write the budget set? Let's say we have two goods, okay, and or budget constraint. So how are you guys constrained in that sense? Your income, whatever you spent on those goods, right, should not be more than your income, right? So how do we write this mathematically? So basically, let's say we have two goods, right? So let's say price of X is Px times X. So this is the amount that you spent on good X, right? This is the money that you spent on good X. This is the money that you spent on good Y. And then, so we said that this should be less than your income, okay? So this is basically, either you can call it the budget set, or you can call it the budget constraint, okay? So this is, you see there is an inequality. So meaning that, all the points, so let's actually draw this first. So what is this set? So let's try to draw this. Well, so let's try to draw what we're going to call the budget line, right? So Py times Y equals to I, right? So here, for instance, I'm going to put here X, I'm going to put here Y. So this is going to be Py times Y, I minus Px times X, right? Y equals to I divided by Py minus Px over Py times X, right? So what is the slope of this line? So this, we're going to call this budget line, okay? Now, what is the slope of this line? What is the slope of this line? Minus Px over Py, right? So that is, that makes a lot of difference, right? So minus Px over Py, right? So this is going to be, we actually say the slope of the budget constraint, okay? The slope of the budget line, all right? And this is going to be the slope. And this is the intercept, right? So let's actually draw this. Basically, this is going to be, so here, this is the y-intercept, I divided by Py, right? And this is going to be I divided by Px. And even these intercepts, you can explain to your grandma. You can actually say that, oh, this is going to be the amount of y when you spent all your money on Y, right? So this is the maximum amount of Y you can buy, right? And this is the maximum amount of X you can buy with your income. So basically, so we draw this, and this is going to be, so the slope will be minus Px over Py. So this is going to be the slope of the budget constraint, right? And then where is the budget set? it's actually this line and all the points inside, right? So this is our budget set. Now let me ask you this. So we haven't talked about the optimal point, right? Which point you choose. Which point is the utility maximizing point, whatever. We haven't said anything about it. But I have this claim, let's say. I say that you can choose a point here. Your best choice could be a point here. Do you agree with me? Do you think this could happen? No. Why not? Okay, so actually it could be, but there's an assumption that we learned which prevents that happening. So what was it? Right, so if more is better, so you guys think that's why I try to say that it is an assumption, okay? It could be the case that I am happiest at that could be my choice, okay? But if there is more is better, then you would say that, hocam, here you're not spending all your income. There is still income to spend. If more goods are going to bring you more utility, then, and with more income you can buy, right, more goods. So just spend more, or all of your income, right? And then buy goods, consume them, you're going to have more utility, right? So that's why as long as there is more is better, the optimal point, we haven't talked about the problem, we haven't talked about math, but you would tell me that the optimal point would be where? It's going to be on the line, right? It's going to be somewhere on the line. We don't know, right? But you know that, hocam, if there is more is better, then this guy should spend all his income. Otherwise, it doesn't make any sense, right? So that's clear. Okay, so then, now let's try to again understand what's going on. So you guys told me that, hocam, let's say there is let me draw an indifference curve. Let's say this is U0, okay? You said that, hocam, this is not going to be the case, okay? So let me actually draw other indifference curves, U1 and another one, U2, okay? So let's call this point A. You said, hocam, if there is more is better, point A cannot be the optimal point. So what about this point? Let's call this B. Here I'm spending all my income. So, okay. But is this the best utility I can achieve given my budget constraint? No. Right? Why?
Because use so much things PX, for example.
So what he is saying is that, hocam, you should try to reallocate your expenditure, right? So change the X and Y share, sort of, right? And then go to some other point, maybe here. You would still be on the budget constraint, right? You would still be on the budget line, but it's going to be, of course, if there is more is better, it's going to be, so let's call this U0.5, okay? It doesn't matter. So, right, so it's going to be on a higher indifference curve, right? So it's going to bring more utility. So which point would be the optimal point then? If I keep doing this, I should stop where? At which point? Oh, okay, it doesn't have a name, right? So now let's give this a name. So this you didn't like, C. So let's call this point D. Okay, so do you think D is good? Right? So, but what's his particular about point D? What's happening there?
Tangent to the
Right, so you know the word tangent, right? So TET, right? So they even used it for the crisis, right? At some point. So it's right. So but it's actually what does tangency mean? No. It does. I mean, it might mean, but in general, what does tangency mean?
Feasible and maximum utility in that feasible.
But still, okay, forget about the utility in math. What does tangent mean? Intersection, or it just touches, right? That's what we say. So, right, so what is about tangency? It should touch, right? And at that point, the slope of that, for instance, here, the indifference curve and slope of the budget line are the same, right? So at the tangency point, slopes are equal, okay? So the slopes should be equal, and it should touch. Okay, I'll write this. But another point I should ask, let's say E. What about point E? What's wrong with point E? We wish, right, we could have, we would like to be on E, but unfortunately, due to our constraint, we cannot be at E, okay? So you guys figured out that, hocam, optimal point is point D, fine. And then you said that, hocam, at this point D, what we observe, so at point D, right, we know that there is tangency, right? So budget line, and right, indifference curve are tangent, right? Right, so at point D, we know that budget line and the indifference curve are tangent, right? So what does that mean? So you said that, oh, hocam, tangency means this. Slope of budget constraint, or budget line, okay, is equal to slope of indifference curve. Okay, so now, what is the slope of the budget constraint? You guys told me. What was this? Minus px over py, right? What is the slope of the indifference curve? Right, it was marginal rate of substitution, or you can actually write it dy over dx, right? And when you keep utility level constant, right? So here, for instance, that was utility level 1. So let's be consistent with whatever we have drawn there, okay? Now, and from here, is this marginal rate of substitution? What is missing? Minus, right? So let's actually do this. So you see px over py, right? Let me put this minus here, minus dy over dx, u is equal to u1, right? This is, as you guys said, hocam, now this is marginal rate of substitution. So you see that what's happening at the sort of optimal point, right? The point that you guys would choose given your budget constraint, right? And you would like to maximize your utility. So what is the condition, apparently? Right? The ratio of the prices, apparently, should be, bless you, the ratio of the prices should be equal to the marginal rate of substitution at that point, right? So apparently, the optimal x and y should satisfy this condition, okay? So this is one thing, and then there is actually another one. So there could be, suppose we have this. Suppose this and this are parallel lines. Then this first condition is satisfied also at point A, if they are parallel. Yes. Why A is not optimal?
Because we didn't spend all of our income.
Right, so for the tangency, right? So there is actually another, when we say they're tangent, you see this slope condition is not enough. There is actually, there should be the second condition where we say, or let me write it here so that we should be on the budget line, right? So that should be the case. Okay, I'll write it here. So here, this is the second condition, okay? And we should be on the budget line. That's why, so for instance, this is satisfied at both point A and D, right? But it should be on the budget line. So at point D, we also have this, right? That's what tangent means, right? Otherwise, if it doesn't touch, it doesn't, the fact that slopes are the same doesn't mean anything, right? So it should be on the budget line, meaning that px times x plus py times y, whatever that x and y, optimal x and y is, and we're going to call them x star, y star, okay? So this is y star, x star. So whatever those optimal guys are, okay, we know that they should be on the budget line, okay? They should satisfy the budget constraint, okay? So now, this is the case. Now I'm going to draw another picture, and then hopefully, finally, you'll say that, hocam, good that we learned those quasi-concavity, convexity of preferences and such, okay? Now, do you think that I check a point and if it satisfies these conditions, you know, it's tangency conditions, right? Slope of the budget constraint and slope of the indifference curve, they are the same. And the point is on the budget line, I can say for sure that it's the optimal point. Can I say for sure? Okay, let's see. Okay, so let me draw you another. So now, let me draw you indifference curves like this. So let's have these guys. Suppose I have indifference curves like this. So I'll also draw the budget constraint. So this is I over px, I over py. Whenever you draw any graph, make sure you don't forget to label your axis, okay? So it is, we wrote this. Suppose I have, let me actually draw it. Okay, suppose this is U0. Suppose I have something like this. So first of all, you guys can tell me, are these indifference curves convex? Are they convex? No, right? Do you remember? So are these guys are convex? No. And we know that, therefore, this utility function is not, you know, like quasi-concave, right? So, okay, so again, let me have some points. So let me call this point, let's say, A. Let me call this point B, okay? And, or let me call this point C, whatever, okay? Now, let's check point A. So check point A. What's happening at point A? Is it tangent to the budget line? I mean, it's tangent to the budget line, right? Meaning that at A, are you spending all your income? Yes. So you're on the budget line, right? It satisfies that condition. And what about the slopes? Slopes are the same, right? There is tangency. Is A the optimal point, the best point? No. Which one is the best point? According to this, write C. You see, if you check these conditions, so let's write this. So both A and C satisfy these conditions, right? Those conditions, right? But A is not optimal. So what is wrong here? What is wrong compared to this case? Okay, I'll put it back up, don't worry, okay? So what is wrong compared to this, right? You see, that's why we try to understand that convexity stuff, because now I'm going to write this down. If there is convexity, okay, you're going to see that if indifference curves are convex, meaning that they have this nice shape, okay? It doesn't even have to be, you know, like strictly convex, but if they have this nice shape, then tangency, checking these conditions would be enough. When you check these conditions and if a point satisfies them, you say that it's the optimal point, okay? If indifference curves are not convex, if they're like this, you check these conditions. If a point satisfies it, still you cannot say that that's the optimal point, okay? So that's why we spent so much time, because you're going to see that the conditions that we're going to use, also mathematically, also, you know, are what we call sufficient, okay? Yeterli, when we have convex indifference curves, right? And what type of utility function was giving convex indifference curves? Quasi-concave, okay? Yes?
Please don't get wrong, but I still couldn't understand that. What's the differences between A and C?
Okay, so let's see how, so remember if there is, of course, if there is more is better, suppose, actually he's right in some sense, because I haven't written this. So when I draw the graph, I should be proper, right? Now, is it clear? Yeah, of course, right? So, but he's right, hocam. I wouldn't know. What if U0 is giving more utility than U1, right? How do I know? So he's right. Of course, suppose that these guys are giving more utility, okay? So U1 is giving more utility than U0, and usually that's, like what we, even we don't mention it, but that's what we assume, but he's absolutely right. Unless I write that, it has no meaning, right? But we know that point C, in that sense, is better than A. But don't forget that at C and A, this tangency condition is satisfied, okay? So now let me write that. So this is, in a sense, we call necessary condition, okay? Gerekli. Ama yeterli değil, okay? So when it's both necessary and sufficient, then it's when you have convex indifference curves, okay? Then you can say that, hocam, I checked these two conditions. I found an x star, y star point. It satisfies this. It satisfies this. It's the optimal point. It's the utility maximizing point subject to my budget constraint. That you can say, okay? If you have convex indifference curves. If you have these type of indifference curves, you cannot say it, okay? So let me write that down, and then we'll see all this mathematically, okay? Now, so here, let me actually write this, okay? So this we say, remember this is a necessary condition, but if we have actually convex indifference curves, it's both necessary and sufficient, okay? So let me write that down. If we have, so let's say, now, do you guys now understand why we try to understand this convexity? Why should they be convex? We try to give some sort of interpretation, right, to your grandma and such. But remember, I was telling you that the real reason mostly is, so that we can use math, right, easily. So that's why we wanted convexity, okay? So if we have diminishing marginal rate of substitution, okay? And remember, these were equivalent. Or let's put it, or convex indifference curves, convex indifference curves. Remember, strictly convex, it actually meant that there are no flat portions, but you can actually put this convex, okay? Here, if you want, I can put it strictly as well. It depends how you define diminishing, okay? If you define diminishing as a strict sort of monotonicity condition, then you should say strict. But if you define diminishing as non-increasing, then it will also include the case constant marginal rate of substitution as well, okay? But don't worry about that. So convex indifference curves, and remember, or we said that quasi-concave, concave utility function. Okay, so if we have these guys, remember they were all equivalent, one of them, then we actually say this tangency condition, okay, is both necessary and sufficient. Okay, to determine, remember how we were reading this, determine, right? So to determine the utility maximizing point, the utility maximizing point, okay? So which is good, which really saves us, because then you just check those conditions and you don't have to check anything else, okay? So this is very important. And that's coming from the convexity of the indifference curves, okay? So this is basically what we do. Now, this was the whole graphical idea behind it, okay? Now, let's try to see this mathematically, okay? But before that, let me actually tell you another thing. So let's try to interpret this guy, okay? What is this? Again, if you need to tell this condition to your grandma, you might say tangency, and such. But still, so what does this mean? If she's like, okay, you get this, I understood this graphically, yes, so this is going to be the best point that you can achieve, right, given your budget set. So this guy will be the best point. Fine, that I understand, but what does this mean? So if you need to interpret this, how would you interpret this? So remember, what was marginal rate of substitution? It was the slope. Remember, it had many. But how did we define it in the very beginning? In order to have one more x, right, how much y you're willing to give up, right? So basically, in a way, the rate at which you're willing to, you know, like trade x for y, right, y for x. So basically, so this is MRS. So this is actually the rate at which you're willing to trade. This is actually the rate at which market is willing to trade, right? So basically, it says that they should be equal. The rate at which you're willing to trade, you know, one good for the others should be equal to the rate at which the market is willing to trade one good for the others, okay? So if you need to, because just for instance, think about this. Suppose you have one x and you're going to give it. So at what price you can sell your 1x in the market? Suppose you have 1x. You want to sell this in the market. At what price you would sell this? Px, right? So with this 1x, then how many y's you can buy? Px over py, right? So this is the price of. So if you give one px, you can buy this many px over py y's. Okay? I don't know. Right? So you see, this is the rate at which market is willing to trade 1x for y. And this is the rate at which you guys are willing to trade 1x for y. Okay? Is that clear? Now you can explain this one to your grandma as well. Right? Okay, good. Now no more grandma business, okay? Now we'll do cool math, okay? So let's start. But what about this? Again, remember, so you're going to see that whenever you would have this case, the one that I just erased, you would be like, hocam, this is good. So this is the easy case, okay? But because we would like to understand what lies behind these stuff, so we would always try to see these extreme cases. Remember, perfect substitutes, perfect complements, or these other quasi-linear preferences. We will all try to find cases where things are not that easy, okay? So this would be your best, you know, like you would say that, oh, hocam, good. So it's a very nice, good function, very smooth. We can actually handle it. So now, for instance, let me draw you, and then we can talk more about it later. But let me, before I move on, so let's actually think of this. What about a case like this? What about a case like this? Okay? Suppose I have something like this. So this is x, right? This is y. And suppose I have my indifference curves like this. So let's say this is my budget constraint again. I over px, I over py, okay? And suppose I have something like this. Let's say this is u0, u1, okay? So let's actually have u3, because I'm going to put u2 in between, okay? So you'll see. So suppose I have indifference curves like this, okay? Now they are also nice, right? They have this smooth shape, okay? Now, but what do you think, for instance, where do you think would be the optimal point? So here, so what's happening here? Any point on these indifference curves, right? Do you think the slope is ever lower than this guy or ever equal to this budget slope of the budget constraint? No, right? So you look, for instance, even at this point, you have a slope like this, right? So at this point, so if you, for instance, here, It's too steep, right? So do you think this is the optimal point, for instance? No. Where should I go? Up or down? Down. Do you think this is the optimal point? No. So maybe, you know, like if these guys were like this, right? At some point, I could have one guy, and then so that this guy would be tangent, right? Somewhere here, it would be tangent, right? But can I go on the negative side? No, right? So where do you think, so I move down. Where do you think I should stop? So unfortunately, because I cannot go down any further, right? I have to stop at this guy. And then whatever, that's why I didn't draw U2, right? So let's say we have here U2, okay? So you see, these kind of solutions, what do we call them? Corner solutions, okay? So from now on, we're going to call any type of solutions, it's a corner solution because you consume only X, but you do not consume any Y, right? So here, so basically you're going to have something like this, X star 0. This is going to be the optimal solution, right? So this is what we call a corner solution. And the solution, you know, like that we had, for instance, a case like this, right? So this is Y, X, this is the budget constraint, let's say, and you have your indifference curve, okay? So let's say this is U1, whatever, okay? And this type of a solution we call an interior tangent solution. No, it's called an interior solution, okay? So this is a corner solution when you have it here, but when you have it, you know, nicely, you know, inside this positive quadrant, so we actually call this an interior solution, okay? So these conditions actually would work when we have an interior solution, okay? So still corner solutions, you have to be careful. This, you cannot say that if there's a corner solution, you cannot say that, hocam, these are satisfied, therefore it's the optimal point, okay? So in those cases, for instance here, you would have your corner solution, as we said, would be here, okay? And what is particular about this point? What's going on? What is the slope at that point? Do you think it's more or less than the absolute value of the slope? It's more or less than the slope of the budget line? More, right? So you see, this guy is steeper, right? So let's try to be tangent, right? At this, for instance, at this point. So remember, so this is like a curve like this. So right, the slope at this point is something like this, but the slope of the budget line is this, right? So you see that, what does that mean? Marginal rate of substitution, do you think it's more or less than Px over Py at that point? MRS is more than, that's why I wanted to give you that interpretation, because check this out now. So this is actually like a hard case, but you see even by intuitive arguments, you can actually figure this out. You guys figured this out, right? You said, the hocam, MRS is more than Px over Py. What does that mean? So we know that, so let's call this E, okay? At point E, MRS is greater than Px over Py. Apparently, you value, what would you do? So basically, so is it time? Right? Okay, let's stop, think, and then we'll just continue in the second hour, okay?